There's a place on earth where nightmares are real, not in our minds, not in fiction, but thriving, breathing, hunting in absolute darkness. It's a place where the rules of life are rewritten, where creatures exist that shouldn't be possible, where evolution has crafted monsters from necessity. And the deeper you go, the stranger they become. Scientists have a name for this phenomenon. They call it abyssal adaptation. But that term doesn't capture the truth, because what happened in the deep isn't just adaptation, it's transformation, a complete redesign of what it means to be alive. We've explored less than 5% of our oceans, yet in that tiny fraction, we've found creatures so alien, so unsettling, that they challenge everything we thought we knew about life on this planet. The question isn't whether these creatures are creepy. The question is why. Why does life become progressively more disturbing the deeper we descend? The answer lies in pressure, in darkness, in isolation so complete that evolution had no choice but to invent entirely new forms. This is the story of descent, of what happens when life is pushed beyond all reasonable limits, and what it becomes when there's no turning back. The ocean is not one world, it's 5. Each zone is defined by depth, by light, by pressure, and by the creatures that have learned to survive there. At the surface, life is abundant. Sunlight penetrates. Photosynthesis fuels entire food chains. Fish dart through warm currents. Dolphins leap. Whales breach. This is the ocean we know, the ocean we romanticize. But this sunlit realm accounts for less than 2% of the ocean's total volume. Below 200 meters, something changes. The light begins to fade. Blues turn to grays. Shadows deepen. We've entered the twilight zone, a transitional realm where day and night lose all meaning. Here, the sun's rays are too weak to sustain plant life. There are no forests of kelp, no meadows of seagrass, only the slow, perpetual drift of organic particles falling from above. Scientists call it marine snow, flakes of dead plankton, fragments of fecal matter, the remains of creatures that died at brighter waters. To us, it looks like dust. To the animals here, it's currency, food, survival. And in this dimness, life begins its first transformation. Many creatures here are translucent, their bodies nearly invisible. The glass squid drifts like a phantom, its internal organs barely discernible against the fading light. The salp, a gelatinous tube, pumps water through its body, propelling itself forward while remaining almost entirely see-through. Why transparency? The answer is strategic. In the twilight zone, faint light still penetrates from above. Anything solid casts a silhouette. Anything visible becomes prey. So, evolution erased them. Other species took the opposite approach. They didn't disappear, they glowed. Bioluminescence, the chemical production of light. It's one of the most common adaptations in the deep sea, yet one of the least understood. Some use it to hunt. The hatchetfish, a small silver creature with eyes pointing upward, lines its belly with light-producing organs. From below, predators see only a faint glow matching the surface shimmer, making the hatchetfish nearly invisible. Others use light as bait. The viperfish dangles glowing lures near its jaws, attracting smaller fish into striking range. Its teeth are so long they don't fit inside its mouth. They curve backward, ensuring anything caught cannot escape. But perhaps the strangest use of bioluminescence is communication. Every night, the largest migration on Earth takes place. Billions of creatures rise from the twilight zone toward the surface. Lanternfish, squid, krill, jellies. They ascend under cover of darkness, feeding on plankton that bloom in shallower waters. At dawn, they descend again, retreating into the gloom. This vertical migration was unknown to science until World War II. Naval sonar operators detected a mysterious layer in the ocean, a false seafloor that rose at night and sank during the day. They thought their equipment was malfunctioning. It wasn't. They discovered the deep scattering layer, not rock, not sediment, but life, an entire ecosystem moving in rhythm, hidden from sight for millennia. The twilight zone is where normalcy ends, where the familiar gives way to the improbable. But it's only the beginning. At 1,000 meters, the last traces of sunlight vanish. We've entered the midnight zone, a realm of eternal night stretching down to 4,000 meters. Here, temperatures hover just above freezing. Pressure crushes with a force of more than 100 atmospheres, and yet this is where life becomes truly inventive. The anglerfish is perhaps the most iconic predator of the deep. The female is a grotesque masterpiece, her body swollen and covered in warty protrusions. From her forehead dangles a bioluminescent lure, a fleshy appendage glowing with bacteria. She drifts motionless in the dark, waiting. Small fish, drawn to the only light they've seen in their entire lives, swim closer the moment they're within range. Her jaws snap open with terrifying speed. But the anglerfish's true horror lies in reproduction. The male anglerfish is born tiny, perhaps 1/10 the size of the female. His only purpose is to find a mate. In the vast, empty darkness, this is nearly impossible. So evolution devised a solution. When a male finally encounters a female, he bites into her skin. His jaws fuse with her body. His bloodstream merges with hers. Over time, his organs atrophy. His eyes disappear. His heart stops. He becomes nothing more than a parasitic appendage, a living sperm bank permanently attached to her flesh. Some females have been found with multiple males fused to their bodies, dangling like grotesque ornaments. It's one of the most extreme forms of sexual dimorphism in the animal kingdom, and it exists because finding a mate in the midnight zone is so improbable that evolution had to eliminate the very concept of separation. But not all creatures here are predators. The barrelly fish has one of the strangest anatomies ever documented. Its head is transparent, a fluid-filled dome revealing two glowing green orbs inside. These are its eyes, tubular and locked in place, pointing upward. For decades, scientists believed the barreleye could only look up, scanning for the silhouettes of prey above, but recent discoveries revealed something extraordinary. The eyes can rotate. They swivel forward when the fish needs to see what it's eating. This fish, small and delicate, possesses vision more sophisticated than many surface dwellers. Its transparent head houses not just eyes, but a complex optical system designed for a world where even the faintest glow is precious information. Then there's the gulper eel, a creature so bizarre it seems designed by nightmare. Its mouth is enormous, grotesquely oversized compared to its thin, whip-like body. It can unhinge its jaws to swallow prey larger than itself. Its stomach expands like a balloon, and at the end of its tail, a glowing bulb pulses with light, possibly used to lure prey or attract mates. But what does the gulper eel eat in such a barren place? Anything, everything. It's an opportunist, one of many in the midnight zone. Food is so scarce here that predators can't afford to be selective. If it moves, it's consumed, and if it doesn't move, something else will scavenge it. When a whale dies, its body sinks down through the sunlight zone, past the twilight zone, into the midnight zone and beyond. This descent can take days, and when it finally settles on the abyssal plains below, it becomes an event. Within hours, sharks arrive, 6-skilled sharks, ancient predators rarely seen by humans, tear into the carcass. Hagfish, eel-like scavengers, burrow into the flesh, consuming it from the inside out. Amphipods swarm in their thousands, stripping meat from bone. For months, the whale sustains an entire ecosystem, and when the flesh is gone, something even stranger moves in. Osedax, the bone-eating worm, colonizes the skeleton. These worms lack mouths or stomachs. Instead, they produce acid to dissolve bone, releasing oils and fats that symbiotic bacteria convert into nutrients. A single whale carcass can support life for decades. It's an oasis in the desert of the deep. And when it's finally consumed, when even the bones have crumbled, the community disperses, drifting through the dark, waiting for the next fall. Below 4,000 meters, we enter the abyssal zone. The pressure here is crushing, over 400 atmospheres, enough to compress a styrofoam cup to the size of a thimble. The temperature hovers just above freezing. The darkness is absolute. And yet, life persists. But it changes fundamentally. In the abyss, food is so rare that most creatures exist in a state of near starvation. Their metabolism slow to a crawl. They move as little as possible. Some species can survive for months, even years, without eating. The tripod fish, for example, has no functional eyes at all. Instead, it uses sensory organs along its body to detect vibrations in the water. It perches on the seafloor using elongated fin rays like stilts, facing into the current, waiting for food to drift past. It can remain motionless for hours, days, conserving every ounce of energy in a place where every calorie counts. Others have taken vision to an extreme. The spookfish has a unique adaptation found nowhere else in the animal kingdom. Its eyes are divided into two parts. The upper half looks upward, the lower half looks downward, but the lower half doesn't use a lens, it uses mirrors. Tiny crystals of guanine inside the eye reflect and focus light, allowing the spookfish to see in multiple directions simultaneously. It's the only vertebrate known to use mirror-based optics. And then there are the trenches, carved by tectonic forces. These are the deepest places on Earth. The Mariana Trench descends to nearly 11,000 meters. If you placed Mount Everest inside it, the peak would still be over 2 kilometers underwater. This is the Hadal zone, named after Hades, the underworld. Pressure here exceeds 1,000 atmospheres. A human body would be crushed instantly. Submarines require walls of titanium several inches thick just to survive. And yet, life is here. Snailfish have been filmed at depths exceeding 8,000 meters. They're fragile, translucent, almost ghostly. Their bones are soft, their bodies gelatinous. They look too delicate to exist, but they're perfectly adapted. Their cells are packed with molecules called piezolites, which stabilize proteins under crushing pressure. Without these molecules, their bodies would collapse. In 2019, scientists discovered a new species of snailfish living in the deepest part of the Philippine Trench. It's the deepest living vertebrate ever recorded. But even they have limits. Below 8,500 meters, no fish have been found. Scientists believe this is a hard barrier. The pressure becomes so great that even piezolites can't compensate. Bones begin to dissolve. Proteins denature. But invertebrates continue. Amphipods, shrimp-like crustaceans, have been found at the very bottom of the Mariana Trench. They're small, translucent, and swarming in the thousands, feeding on microbial mats and organic matter. When scientists retrieved samples, they found something disturbing. Microplastics, synthetic fibers, chemical pollutants. Even at the deepest point on Earth, over 10 kilometers from the surface, human waste has arrived. The deep is not isolated, it's connected, and it's vulnerable. But perhaps the most unsettling discovery came from hydrothermal vents. These are cracks in the ocean floor where superheated water, rich in dissolved minerals, spews from the Earth's crust. Temperatures can exceed 400 degrees Celsius. The water is toxic, filled with hydrogen sulfide, methane, and heavy metals. Nothing should live here, and yet entire ecosystems thrive. Giant tube worms, some over 2 meters long, cluster around the vents. They have no mouths, no digestive systems. Instead, they host symbiotic bacteria inside their bodies. These bacteria convert the toxic chemicals into usable energy. It's a form of life based not on sunlight, but on chemistry, a food web powered by the planet itself. These vents exist in complete darkness, under crushing pressure, in water that would kill most organisms in seconds, and life not only survives, it flourishes. If life can exist here, scientists ask, where else might it exist? On Europa, Jupiter's icy moon, where an ocean hides beneath a frozen crust, on Enceladus, Saturn's moon, where geysers of water erupt into space. The deep sea is teaching us that life is more resilient, more adaptable, and more tenacious than we ever imagined. But it's also teaching us something else. The deeper you go, the more life defies our expectations. The more it challenges our definitions. The more it forces us to ask not just what life is, but what it can become. So why do deep-sea creatures get creepier the deeper we go? The answer is simple and unsettling. Because the conditions they face become more extreme, and evolution responds with more radical solutions. At the surface, life follows familiar patterns: fins for swimming, eyes for seeing, mouths for eating. But as we descend, these patterns break down. Light disappears, so creatures either vanish into transparency or they glow. Pressure increases, so bodies become soft, gelatinous, compressible. Food becomes scarce, so predators develop enormous jaws, expandable stomachs, and the patience to wait months between meals. Every strange feature, every unsettling adaptation exists for a reason. It's not horror, it's survival. But there's another reason these creatures unsettle us. They remind us of how little we know. More people have walked on the moon than have descended to the deepest parts of the ocean. We've mapped the surface of Mars in greater detail than our own sea floor. Every deep sea expedition returns with creatures unknown to science. Transparent fish, bioluminescent worms, jellies with no clear anatomy. Each one forces us to expand our understanding of what life can be. But time is running out. The deep sea is not untouched. It's not pristine. Microplastics have reached the Mariana Trench. Commercial fishing drags nets across the abyssal plains, destroying habitats that took millennia to form. Mining companies eye the sea floor for rare minerals, planning to extract them at scales that could devastate entire ecosystems. And we're doing this to a place we barely understand. Scientists estimate there are over 1 million species living in the deep sea. We've identified fewer than 10% of them. Every species we lose is a solution to survival we'll never study, a chemical compound we'll never discover, a story of adaptation we'll never understand. The deep sea is not separate from us. It produces more than half the oxygen we breathe. It regulates the planet's climate. It sustains food webs that reach all the way to the surface. And it holds secrets we're only beginning to uncover. The creatures of the deep are not monsters. They're survivors, masters of adaptation in the most hostile environment on Earth. They're proof that life doesn't need light. It doesn't need warmth. It doesn't even need the familiar rules we take for granted. It only needs a chance. And perhaps that's the most unsettling truth of all. Not that these creatures are strange, but that they exist in a world we've ignored, a world we're destroying before we've even seen it. The deep sea is the last great frontier on Earth, and it's disappearing. The question isn't why deep sea creatures are creepy. The question is whether we'll protect them before it's too late. Because once they're gone, we'll never know what else was down there, waiting in the dark.